Good morning, everyone. It is week 5 of online learning, and today our lesson is on the percent rate of change formula. So this is an application of exponential functions. On our agenda, in the video, we have a do now, definitions, and then examples. And then your classwork assignment, your grade will be based on your completion of the Google form. Okay, so for the do now, take a second to do this on your own. The directions are to rewrite the following percentages as decimals. So pause the video and come back when you've done that. All right, so hopefully if you've done this, and if you have, you can skip ahead to where I give all the answers, but if you needed a little help, the way we convert a percentage to a decimal, we have to think 87% is out of 100%. So really this is 87 100ths. And if I divide 87 by 100, you can use your calculator. You should get 0.87. Same thing for 60. 60 divided by 100 will be 0.6 or 0.60. 3 divided by 100 will be 0.03. So you got to be careful to make sure you have this 0 in here as well. There's a trick that you move the decimal point 2 over. So when we have 3, we have to include that 0 as a placeholder. All right, finally 7.5 over 100 will be 0.075. Same thing, when I move the decimal place over 1, 2, I have a 0 as a placeholder, and then the 5 is still hanging out on the end. Okay, so we're going to need to be doing this today when we study percent rate of change. Real quick, I want to recall our old definitions, right? So we used to have this formula, which is still our basic exponent formula. F of x equals a times b to the x, where a is our y-intercept, which would also be the starting value, or the initial value, the starting point, right? When we consider our y-intercept, we're thinking, okay, this is what we start with. And then b was our rate of growth or decay, right? And we remember that growth is if we had b greater than 1, decay is if we had b less than 1, right? So now what we're going to do is we're going to have a more specific version of this formula. F of x equals a times b to the x. That's still the overarching formula here, but we have more specific values, okay? So the percent rate of change formula. First, a percent rate of change is how much something's changing based on an existing value, okay? So P here, that's our y-intercept still, or our initial value. So a lot of these problems are going to be talking about money. So if I buy something, then the initial value is whatever I spent on it, okay? F is representing our function and our output. And then in here, instead of B, we have 1 plus R. So R is now going to be our rate. And our rate is always going to be expressed as a decimal, like how we did in the do now, okay? So this rate will always be expressed as a decimal instead of a percentage. So I'll give you some examples in a minute, but we'll be computing percentages into decimals, just like we did in the do now. And finally, T is going to be time. So T could be months, hours, years, any unit of time, and it'll specify in each problem. Okay, so the objective today is just to be able to define the parts of this formula. So here's my first example. A youth group has a yard sale to raise money for charity. The group earns $800 but decides to put the money in the bank for a while. Their local bank pays an interest rate, so I'm going to underline rate, of 3% per year, and the group decides to put all of the interest they earn back into the account to earn even more interest. Write a formula to model the amount of money the youth group will have in the bank after each year. Okay. So let's underline the question first. Write a formula. That's what our goal of this problem is to do. So to write a formula to model the amount. And I already went and underlined rate because I know rate is a keyword. Okay? Maybe we'll make this a box. We box rate. Let's circle our 3% and circle our $800. Okay, so we've got $800. What is $800? And I want to be thinking of my formula, right? My formula is F equals P times 1 plus R to the T. $800, I'm going to think, okay, is that the initial value, the rate, or the time? Initial value, right? We start with $800. So my initial value is going to be 800. So P here equals $800 initial amount or starting amount. Then we know the rate is 3% per year. So R is going to be, if it's 3%, just like in the do now, if rate is 3%, then I need to convert that to a decimal. So 3 divided by 100 will be 0.03. So my rate is 0.03. Now I don't have any numbers. We know time is going to be in years. So right now I can substitute everything into my formula. So I'll have F equals 800 times 1 plus 0.03 to the T. And I can simplify this to be F equals 800 times 1.03 to the T. And this is going to be my final formula. Okay? So what we'll do in my next lesson is be using the formulas to compute an amount of money. So say we want to know how much money will they have after 3 years or something like that. Okay? So that's example 1. If you need to, rewind the video and watch it again. I'm going to move to example 2. Okay, so number 2. Doug drank a cup of tea with 130 milligrams of caffeine. Every hour, the caffeine diminishes by about 12%. Write a formula to model the amount of caffeine remaining in Doug's system after each hour. All right, I'm going to underline they want us to write a formula. I'm going to circle my numbers. We have 130 milligrams of caffeine and 12%. Now there's one more key word here. The caffeine diminishes. Diminishes. Diminishes means it goes down. Okay? So with interest, the bank, you're earning money, right? So that was increasing. You're increasing your money in the bank. But here, if we're diminishing 12%, we're going to have to figure out, okay, what's my P value and what's my R value? And there's going to be something a little different with this R value. Okay? P value, initial amount. So we're talking about amount of caffeine. The initial amount, what he started with, Doug has 130 milligrams of caffeine. Okay, now R is rate, and we're looking for that percentage, right? So we've got 12%, but we know this needs to go to a decimal. So if I divide 12 by 100, I'll get 0.12. But now we have to think about this keyword, diminishes. Diminishes really means we go minus 12% each time. Negative. So all these values need negatives. So we have a rate that is negative 0.12. So when I substitute these values into my formula, and I have F equals P times 1 plus my R value is negative 0.12 to the t. That's really like t minus 0.12 to the t. And you can use your calculator for this. But I know that's going to be times 1 minus 0.12 will be 0.88 to the t. So what we know about b values, since we have a b value less than 1, we have exponential decay, right? Which makes sense because we're talking about diminishing. So the amount of caffeine is going down as the day goes on, right? So maybe if you drink coffee, same thing. The amount of caffeine in your system goes down throughout the day. All right, we're going to do one more example, and then I'm going to ask you to do that Google form. Okay. The following formula models how much money a customer will have each year from a savings account. M equals 450 times 1.03 to the t. How much money did the customer initially deposit into the savings account, and what is the percent rate of change for the savings account? What does that mean? All right, so we're saying in the first question, how much money did the customer initially deposit? If we're talking about initial values, I'm thinking p-value, right? So p. So what's p in this scenario? Well, if I compare to my formula, right? If I look at my formula here, I'm going to say, okay, what's in the p spot? So f equals p times 1 plus r to the t. Here I've got m, which is fine. And then instead of p, I have 450. So it seems like that should be p equals 450 because we always have the p value without the exponent, right? And if we want to be specific, that would be $450. That would be our units. Okay. So we initially deposited $450. What is the percent rate of change? So we want to find the rate now. And they're asking for a percent, okay? What's the percent rate of change? So if I need to figure out my R, because rate we know is R, and I know that in the parentheses, this should be 1 plus R. So if 1.03 is equal to 1 plus R, what should R be? So we can solve this algebraically, subtract 1 from each side, and we'll get R equals 0.03. Okay, so we've got an R value, but is this a percent? No, right? Because we know our R value is always in that decimal form. So now what we have to do is multiply this times 100 to get that this is, okay, 3%. So to go from a decimal back to a percentage, we multiply by 100. Before, we went from a percentage to a decimal, we divided by 100, right? Those are inverse operations. Okay. So then we say, what does this mean? So we've got these numbers. So we know the customer initially deposited $450 into the account. The percent rate of change is 3%. So what this means is, and I'm looking at my units here, every year the customer earns 3% interest on their initial deposit. So initially it's on their initial deposit, but really it's on the money in the bank. On the money they have in the bank. Okay? So that 3% means we have every year the customer is earning 3% interest on the money in the bank. So you're going to have something very similar in the Google form, and it's going to give you instant feedback on if your answer is correct or not. So if you don't get everything correct, take it again, try again, and see if you can improve your score. All right? Good luck. Make sure you tune into my office hours if you have any questions, or text me. All right. Talk to you later.